We use the example in class that the average American family has 1.9 kids. Let's see what the average family in our class has. So if kids in our class have a family with either one kid in their family, two kids in their family, three kids in their family, or four kids in their family, if we want to know what the average number of kids is in our class, we wouldn't just do 1 plus 2 plus 3 plus 4 divided by 4. We would want to know the weighted average. So it would matter how many people have one kid in their family, how many people have two kids in their family, how many people have three kids in their family, and how many have four kids in their family. Because let's say almost everybody in our class has four kids in their family, but one person has only one kid, well then our average is going to be much closer to 4 kids. So let's use this as an example. This is an example like the weighted atomic mass for our elements, but we're going to use family size. So let's say that out of our class, 3 families have 1 kid, 7 families have 2 kids, let's say 5 families have 3 kids, and let's say 4 families have 4 kids. So that's a total of 3 plus 7 is 10, 15, 19. There's a total of 19 families. What we want to do next, we want to look at, of those 19 families, what portion of them have 1 kid? What portion of those 19 families have 2 kids? What portion of those 19 families have 3 kids? And what portion of those 19 families have 4 kids? So that's what we're going to call abundance. And this abundance is basically a percentage, because isn't percentage part over whole times 100? We're going to do that same thing. We're just not going to turn it to a percentage by multiplying by 100 because we need to leave it in that raw form. But it's essentially part over whole, percentage of how many of each of these, how many of our total 19 families have 1 kid, 2 kids, 3 kids, 4 kids. So to do part over a whole, we're doing 3 over 19. I'm going to set it all up first and then I'll do my math. 7 of the 19 have 2 kids. 5 of the 19 have 3 kids, and 4 of the 19 have 4 kids. So let's do that math. 3 divided by 19, and I'm going to keep a lot of digits here just so I don't end up with a lot of rounding error. So we've got 0.157889. 7 out of 19 families is 0.36842. 5 out of the 19 families is 0.2631. If I round that, it's going to be 6. And then 4 out of the 19 families, 0.2105. And if I round that, it's going to be 3. So these are essentially our percentages of our total number of families, how many of them have 1 kid, how many of them have 2 kids, how many of them have 3 kids, how many of them have 4 kids. If we multiply it by 100, it would be percent. So we could say 15.8% of our families have 1 kid, 36.8% of our families have 2 kids, 26% of our families have 3 kids, and 21% of our families have 4 kids. What we can take now with those portions is we can take each one of those portions and multiply it by the number of kids in that portion. So if 0.15789 of our 19 families have 1 kid, we're going to multiply by the 1 kid they have. Again, I'll set all this up and then I'll do the math. If 36% or 0.36842 of our families have 2 kids, we want to consider that. So these are now weighted masses, or not mass. It's mass when we're doing isotopes, but weighted family size. Okay, if 26%, or another way to say 26% would be 0.26316 of our families have 3 kids. We want to have a weighted family size, taking into account what portion of our families have 3 kids. If 21%, or Another way to write 21% is 0.21. If that portion of our total families has 4 kids, we want to consider what portion of our families has how many kids. So I'll do this math. Well, that's going to be 0.15789. 36842 times 2. Next one, 0.26316 times 3. All right, so this now is the weighted family size. It's considering what portion of our total families has how many kids. Once we add these all together, we're going to get our total weighted family, average family size. So let's add all this together. So 0.84212 plus 0.78948 plus 0.73684 plus 0.15789. Our total weighted average family size for this class is 2.53 kids. So considering all 19 families represented by how many kids represented in this sample group, the weighted average family size is 2.53 kids. This is the same thing we do when we're determining average atomic weight for different isotopes. Each of those different isotopes have so much abundance, so much percent of the total isotopes with that mass. So we use that to consider what is the weighted average. So in this case, the average family has between 2 and 3 kids.